has their graphing calculator. So we talked, okay, I have some warm-up slides here. So let's go through those, what we talked about yesterday. So yesterday's learning targets were to be able to find the zeros on a graphing calculator, to be able to find all the extrema, which are maxes and mins, and determine domain intervals. What does domain intervals mean? You're using what letter if you have a max or min to determine whether the graph is increasing or decreasing. You're going to use, what does domain mean? X, right? Domain means X, so you're going to use the X values from those maxes and mins and write intervals where the graph is increasing or decreasing. And increasing or decreasing just meant as you go left to right, is it going up or down? Today we're going to add in concavity. We're going to talk about an inflection point a little more, and then we're going to talk about concave up like a cup and down like a frown. And then we're going to talk about average rate of change, which feels like a totally unrelated topic, but it's easy. All right, so here's the warm-ups I have. They look tiny from here. Let me see if I can make them any bigger. Okay, well, it's a little cut off, but at least we can see a little better. It says identify the x-intercepts. So I don't want to have to put in any equations in my calculator right now. Where are the x-intercepts on this graph? Can anybody tell at least one of them? -1. And then if we count over here, I think 1, 2, 3, 4, and 5 look like they're both x-intercepts. And on the quiz, I don't care if when it says, I think it actually says zeros maybe, I can't remember, or x-intercepts. You could list them or you could write them as ordered pairs, which is what your, is what your calculator should give you. I don't care what you do. Okay, y-intercept. This is important because how do you find the y-intercept? It's not on your calculator as a special feature. Yeah, if you just go to either the table or I just hit trace 0, right, the 0 button, then enter and it will go to where the x value is 0. Can you tell what this is? Antonio, can you help us? Antoine, I don't know. I totally messed your name up. 1, 2, 3, 4, 5, 6. I'm going to go with 8. All right. On this guy over here, does it ever cross the x-axis? Nope. What about the y-intercept? Does it have one of those? Yep. Looks like it's crossing down here at -2. Okay. Then we're going to review... oh, these are calculator ones. Oh no, it says algebraically. This is kind of an intro to more factoring we're going to do later. So we're going to do this without using our calculator. We're going to find where this equals 0, and this, remember, is when y is 0. So you'd have points like this, okay? And the y-intercept is when x equals 0. Can you guys find that one quickly? What would happen if I put a 0 in there? I'd get out a 9. Okay, so the y-intercept is easy algebraically. The x-intercept, this is a concept we're going to do later. Does anybody know how you could factor an x to the 4th? Yeah, x squared and x squared would, when you multiply them together, become an x to the 4th. Does that make sense? Okay. And then there's x squareds in here, and to get a +9, I'm thinking we need a -1 and a -9. We'll practice this a lot more before I require you to do it, but, and then that would give you a -1x squared, a -9x squared, so a total of -10x squareds in the middle. Help me factor this further though. How does x squared minus 1 factor? Difference of squares, everybody good? So the second one would factor x minus 3, x plus 3. We good? So where are all the zeros of this function? If I set each of those equal to 0, I would get 1, 3, and negative 3. Okay? So those are all the zeros. I'm not going to rewrite it. All right, that's a concept when we get to polynomials we'll do some more of. Algebraically here, this is a little bit trickier. The zeros are when y equals 0. Can you go back to what we did about a week ago and try to solve this? What would you do first? Add 3 over here, and then square both sides. We were doing them the other direction, but so this would become 9, and this would become x plus 4. If we subtract 4, we get, so this one should have a 0 if you put in a 5. Did I do something wrong? No, that's right. 5 plus 4 would be 9. Square root of 9 is 3. Minus 3 is 0. Okay, that worked. Y-intercept. How do you find the y-intercept always? This is why I put this on the review, because we have not reviewed y-intercept for a while. You put x equals 0 in. So what is the square root of 4 minus 3? Square root of 4 is? Minus 3 is? Negative 1. So 0, negative 1 should be the y-intercept for that one. All right, that was a little quick review on those. Now we're going to review increasing and decreasing. Anybody tell me how this goes? All we do is look at the graph from what? Left to right, and we decide if it's going up or down. But we have to give intervals based on x values. So I'm going to label this as -2. I can't tell. 1, 2, 3, 4, 5, 6, 7. So -2, 7. And over here, I'm going to label this as 2, 1, and 4, -3. Because that will help us do the increasing and decreasing. All right. So somebody give me an interval where this one is decreasing. Okay. It's actually going forever to the right at decreasing. You're right. It looks like it stops at 1 right there, but that's an arrow. So it would be decreasing from -2 x value forever to the right. So increasing is what, guys? Negative infinity till we hit that -2. Everybody good on yesterday's lesson? Okay. What about this one? What do you want to start with? Increasing or decreasing? Increasing from the left until 2. Sorry, that doesn't look like a 2. It's very tiny. And then what? 2 to 4, it is decreasing. And then from 4 to the right forever, it is increasing again. Any questions? You got that from yesterday. Okay. Today, I want you to type this in your calculator. We're going to practice finding maxes and mins one more time, and then talk about increasing and decreasing before we do concavity. So one calculator question. Let's see. I have it typed in. Does a Zoom 6 work? Are there any hints from the graph about what a better window might be? It works. Zoom 6 works. But do you notice here that they put -4 and 4? So if I were to change my X window to -4 to 4, it would stretch it out a little better and we could see those points. And that was a hint right from the graph paper they gave us. Raina, can you find that max for me right there? Ben, can you find this little min right here, this one? Samantha, can you find this max? And Cheyenne, can you find this min way over here? Raina, yep. Okay. What does it say? Negative 0.09. So yeah, it's just below. Okay. One more time. Negative 1 point and negative 0.09. Okay. So is that a max or a min? It's a max, right? Is that what you use to find it? Okay. So what goes in what blank here, guys? Do you remember when it writes it this way? The relative max of the function was negative 0.09, which occurs at x equals negative 1.5. Did anyone else try to find that one and get those same numbers? All right. The next one was a min, and I don't remember. Yeah, Ben. Okay. I'd really only rather write the x's over on the graph because that will help us with the increasing and decreasing. And I don't have much room to write them. Okay. I don't remember. Yes, Samantha? Negative 2.64? 44? Sorry. Old lady ears and masks and air conditioning and whatever else is competing with my... who was the last one? Cheyenne? Okay. I think I put those all in the right blanks, right? Max, min, max, min. Okay. Is there an absolute max or min for this graph? No, because on one end it goes down forever, one end it goes up. Okay. Now, to fill in all these increasing and decreasing, we have to go carefully. Coming from the left until negative 1.5, it was from negative infinity till negative 1.5, it was increasing, right? Who can tell me the next piece? Okay, it's decreasing from negative 1.5 to negative 0.42. Again, I tried to write those on the graph so that just the x's so that I could easily see that. Tiny little increasing. Anybody got that one? Negative 0.42. Is it to positive 0.42? Right? Okay. Natalie, can you tell me the next stretch? Sure. Okay, but that's a y value. Be very careful. This is what happens on quiz all the time, okay? When you're giving these intervals, it has to be the x value at that point. Okay. I think it was 1.5. Just, yeah. And finally, Yeah, there's another increasing piece from 1.5 to infinity. Okay. I do hereby solemnly swear that I will not give you one with that many intervals on the quiz, okay? Too much, too much. Okay. We're going to skip the one at the bottom of the page right now and go on and talk about concavity, and then we're going to come back to that one. All right. Concavity of a graph. First of all, concavity is based on an inflection point, and an inflection point is where the graph changes bend. Okay? It changes the concavity or bend in the graph. See how it's not a max or a min. So between here and here, it's actually where a tangent line would be vertical or horizontal. It's a mess, okay? What you need to know, because it's a definition you will learn in calculus, what you need to know is it's where the graph changes bend. The direction it's bent in. I don't know what I want to, where I want to put quotes. So, and it occurs for us, it occurs between a max and a min. Between the extrema or the maxes and mins. So this is showing some different graphs and where it changes. Do you see that there's not a max or min, but it changed the way it was going, kind of changed the direction? Yes. What? Yes, I'm sorry. Here, just going up, and it's still going up, but it changes the bend. Do you see what I'm talking about there? Okay. The good news is you're not going to have to identify where it changes the bend. It's an estimate because we can only find the exact value using calculus. So in the past, what I did for these inflection points was I had students just estimate. This year, what I decided to do is I'm going to give you the inflection point. You just have to identify the concavity, okay? So in a picture like this, that changes bend somewhere between this min and this max. Do you see what I'm talking about, guys? Okay. I'm going to tell you what that point is. We're going to practice a little bit where you just kind of guess, but I'm going to tell you on the quiz. I'm going to give you a value to use. It's not the actual inflection point necessarily. So back here, what those inflection points help us determine is the concavity. There are two concavities. It can be looking like this, which is called concave up. And it's like it would hold water like a cup, okay? Concave up like a cup. And the other option is concave down, which is this idea. It's bent this way, and we say down like a frown. I used to say that's like a grin or a frown, but Miss Gupta does up like a cup, and that rhymes, so we'll go with it, okay? So on this picture, it's pretty clear to me that this is up and then this is down. This one is a little bit trickier, but this piece is down if you continued, okay? And then this piece is up. Now that's not going to hold much water, right? But still bending that way. This one is up, this one is down. What would this one be? Up and then down, right? Okay, so on this picture, I think you don't have this one either, but this is up, this piece would be down, and this piece would be up. And this is, we're not going to do this. This is more something you do in calculus, but you will have concave up but decreasing, concave up but increasing, and so on. We're not going to worry about that. Okay, so I want you to go back to the one we skipped. We are not going to do everything it asks for here. It asks for a lot of stuff. What I would like us to do, so let's graph this first of all. Type it in your calculator. 2x to the 6th plus 2x to the 4th minus 9x squared. And my window is actually really good, the window that had a -4 and a 4 as the x's. You can leave it at -10 to 10. I'm actually gonna put this over here so that we can label it. Oh, sorry, didn't mean to write on it. All right, so again, my window's -4 to 4 for the x's, and then -10 to 10 for the y's. And this is the equation I put in from worksheet 4A. All right, I need the maxes and the mins on this one. Elena, can you find one of the mins for me? Maddie, can you find the max? It might be 0, 0. I can't really tell. I think the mins are symmetric. This is an even function. Does everybody see all the exponents were even? So I think whatever this is, the other one's just the opposite sign. Was this 0, 0, Maddie? Okay. So this is at 0, 0. Did anybody find this one? Yeah, Elena, what'd you get? 0.96. And then the y value was? And then I'm thinking this one is 0.96, but still -5.03. Does that seem okay with everybody? All right, I'm not gonna, the direction said we were also supposed to find a bunch of other stuff. Now, let's do increasing and decreasing for practice. What is it doing first? Decreasing from the left until -0.96. And is it decreasing anywhere else? Decreasing here, right? Everybody okay with that? As we go left to right, those were the two places it was going down. The two places it was going up were -0.96 to 0. Again, we're only using x values, and 0.96 to infinity. Now, I shouldn't have scribbled on my graph so much because I want to talk about concavity. Okay. Concavity does not use maxes and mins. It uses inflection points. So I'm going to go back to my calculator, and I'm going to trace along and try to figure out, where's the rest of my calculator? Here we go. Trace, sorry, and try to figure out where I think the inflection point is. And I'm just going to pick somewhere in here. Can I just do maybe 0.5, guys? Can we use that one? I will give you something to use on the quiz, but I'm going to say 0.5 is where it switches. Is that all right? And that would be -0.5 on the other side. Does that look like it might be where it switches? All right, we're just going to use those. And the y value will be given to you on the quiz, but do you need the y values? Not for what we're going to, for the intervals you don't. So this is -0.5 and this is +0.5. All right. So can anybody tell me where it is concave? What is this first piece doing? All of that is up. So concave up. we would write from the left until negative 0.5. Is there another place that it's concave up? Yes, from 0.5 off to the right, that is also up like a cup. And then the piece that was down like a frown is this piece in here that goes from what? Negative 0.5 over to positive 0.5. So again, when you state concavity, you use X intervals. Everybody got it? Can you go back to the next one? On the next page, there's one more to do on the calculator. Can you graph this one, x cubed plus 9x squared? And find any maxes and mins, give yourself a picture, all that good stuff. I don't think my window's working. Ooh. Gotta have a high window for this one, yes? Is anybody else getting that it's gotta be, the Y max has to be higher? I don't know, I'm gonna guess like 50, and it's probably way too high. Yep, not high enough. Did I type it in wrong, or someone else get in that high? That might mean you have something else typed in. This is part of the graph. Yeah, that's why I'm saying you have to find the top. It's all a cubic. It's not a line, it's all part of the cubic. So my window needs to be like 150 maybe on the top for the Y's. Now it looks like a cubic. Okay, what we just discovered was that we have to know something before we go to the calculator. We have to know that a degree 3 should have that shape, okay? Remember we talked about end behavior. It's odd degree, so it should have one end up and one end down. Otherwise, when I just did, if I had just done zoom 6, I might have thought it was just a parabola, right? Or I had that negative 4 to 4 window. I might have thought parabola and a line. I knew it was not right because it's a degree 3, the end behavior. It needs to all be connected. So what did I end up with? 150? All right, we need to know the max and the min. Is the min just 0 or not? Trace min negative 5 and 5. Yeah, that's 0, 0. That's a lovely way of saying 0, 0. Do you see how those E's, guys? It just means 0, 0 what? Totally depends on the, yeah, I got it to say 0, 0. Did you do min, though? Okay, sometimes it'll work perfectly. I just picked really bad numbers, I guess, for my left and right. Then the max. Did anybody find the max? Okay, I'm going to go, whoops. I'm going to pull this down and move this over here. And we had 0, 0 and negative 6, 108. Okay, we need how many inflection points on this? If they're only found between maxes and mins, how many we got? Just one. Anybody want to estimate? Trace along there and see what you want to pick. Somewhere in here it switches from holding water to down like a frown. Can we go with like negative 3? Is that okay with everybody? I would tell you, I would say there's an inflection point at negative 354. So in here somewhere is negative 354. All right, do we need to do increasing and decreasing so you know the difference between that and concavity one more time? Or you got increasing coming from the left from negative infinity until the max. Then it is decreasing from the max to the min. And then it is increasing again from the min to the right. But if the inflection point we estimated was at negative 354, and I think on the homework there's a couple where you have to estimate the inflection point, and I don't care if it's a decimal or you just pick a nice number. Now, somebody tell me the concavity and we'll be done with this idea. What is the first piece? Concave down. But you're using the x values from that inflection point. So concave down from negative infinity till negative 3, and then concave up from negative 3 to infinity, the right. Seem okay? If I give you the inflection point and you just have to graph it and decide which side of the inflection, and it's a cubic, I think, on the quiz. I didn't give you one that has like 4 pieces, okay? Can we just do the concavity here? If I pick this point right in here to be 0.8, negative 2, can anybody tell me the concavity? What does it start? Down or up? Coming from the left, it's down. So how do I write that? Again, I gave you the inflection point like I would on a quiz. And then to the right of that, concave up from 0.8 to infinity. Yes, no, maybe. Okay. The second part of the lesson literally takes like 5 minutes because all it is finding slope. Anybody need more time? All right, second part of the lesson. It says average rate of change. The average rate of change between any 2 points on a function is the slope of the line through those 2 points. Right there. So the line through any 2 points in a curve is called a secant line. The average rate of change from the interval x1 to x2 is the slope of that secant line. So I'm going to write this in here, but you just really need to remember that it's slope, okay? The y values, if you had an a and a b, if you put in the a value and you get out an answer, and then you put in the b value and you get out an answer, those would go on the top over a minus b. We're not going to talk about it that way. We're just going to make some sense of it, but that's the fancy notation. Or you could switch the b's and the a's. The order doesn't matter. Everybody got something down? Now let's talk about what that really means. So this is your a and this is your b. So we are going to find f of 3 and f of 5. Can someone put a 3 into that little equation and someone put a 5 in, please? Negative 2 times 3 squared plus 5. Okay, did anybody do the 5? Negative 2 times 5 squared plus 5. Negative 45 maybe? Okay. So we have 2 ordered pairs. Does anybody know what the 2 ordered pairs I'm talking about are? What did we put in to get out a negative 13? So we put in a 3, got out a negative 13. And then we put in a 5 and got out a negative 45. Is everybody okay with what we did? This was an interval from 3 to 5. We had to put in a 3, get out the corresponding y value, put in a 5, get out the corresponding y value. The last thing you have to do, and it's called average rate of change, and so students forget what you have to do when they average the numbers. No. What you have to do is find the slope, and remember, slope is change in y over change in x. Whatever order you want to do it in. If I do negative 13 minus negative 45, then I go 3 minus 5. You could switch the order on those as long as you're subtracting. This becomes 32. Did anybody get that? Over negative 2 or a negative 16. Anybody else getting that? Okay. This next one, I don't know. Do we need to do both of these? We can write it down, but someone might need to help me. I think that would be 81 minus 54 plus 3 minus 1. I don't know. That's a lot of plugging in. Tell you what. I'm going to assign some people. If I could remember everybody's name, I'd be really happy. I want to say Kayla. That's not right though, is it? Kaylee. Can you do the f of negative 3 for me? Jada, can you do f of negative 2 on this one? Adriella, can you put a 1 into this last one here? So when we get there, we're ready. Tell me your name. I just am drawing a total blank. Emma? Okay. Emma, can you put a 3 into this one? I'm so frustrated. I thought I had everybody down. If I had seen your name, I could have put a face, but I just drawing a total blank. Okay. Who did negative 3? Did you already do that one? 29. Did anybody already do the negative 2? Okay. Did anybody do the 1 over here? Or the 3 yet? One? Anybody do the 1? 1 plus negative 5? Okay. And the 3? 27 plus 45. Yeah, I can't do that one in my head. It's hurting my head. All right, how do we finish this problem number 5 then? This means that we had an order pair of negative 329, and this means we put in a negative 2 and got out a 1. So then we do the slope. I got negative 28. Did anybody else get negative 28 on that one? Yes? Emma, did you finish putting the 3 in? 107? 47? My ears. Okay, so we put in a 1, got out a negative 5. We put in a 3, got out a 47. So 40, we can do it in the order it's written. Negative 5 minus 47 over 1 minus 3 would be negative 52 over negative 2 or positive 26. Yes, no, maybe? Okay. It's an easy concept, just a lot of calculations. We good? All right. The homework is not Delta Math. I'm sorry, but Delta Math, well, it does do rate of change. It does not do concavity except in calculus, and they talk about it in ways we aren't good with talking about it. So I want you to do the worksheet 6A. It says, read the directions carefully at the top because you have to find a bunch of stuff. But the first two, it says, don't bother to use a calculator, just estimate from the graph, okay? Do you see what I'm talking about? Then 13 and 14, it says, use the calculator and find all those maxes and mins, and be very careful you find everything it asks for because it asks for zeros and everything. And then on the bottom, it's just some average rate of change questions. Do we have time to knock out one of those average rate of change questions together? Somebody pick one. Read me the equation and tell me the... Is there one with a radical? What does the radical say? X plus 5? That's it? And what is the interval they want us to do? Okay. Between -1 and 7. So I would do f of -1, which would make that 4. The square root of 4 would be 2. So I'd have -1, 2. And then f of 7, would be the square root of 12. Can anybody give me a decimal? Oh, I got it. Maybe square root of 12. 3.5, 3.46. Let's just go with 3.5. Okay. 7, 3.5. Okay. What numbers do I subtract? Somebody help me. Yeah. I'm going to do it 2 minus 3.5 over -1 minus 7. -1.5 over -8. I got 0.1875 or 3/16. Again, we rounded, so anything would have been okay on that one because of the radical. What number was that? Okay, so I did one of your homework problems for you. Just remember how we did that. Because somehow on the quiz, when they see average rate of change, everyone wants to average some numbers, but it's not averaging. It's just slope.